Hello class, today what we're going to be doing is the pre-movie Mad Libs setup. This is actually just going through all the requirements. Stay tuned to part 2 and 3 where I go through the code line by line and then also actually how to do it. So right now what we're doing is we have 3 different imports up here. This is just to import all the code to make sure the applet and the math and all the other stuff works. We're extending applet so we're no longer doing void main. And make sure you have 3 things for your pre and 3 things for your post. You will lose 30 points if you don't do that. That would be a bad thing to do. I would not do that. Next thing what we're going to do is we have these percentages. And what these percentages mean is we have 3 options and each percentage has 33% chance of happening. So what that means is when I go to my applet and I change the width, these words change and they have a 33% chance of showing up. This one has 25, 25, 50. It still has 3 options, but the percentages are different. And then this one has 8 options, which means we have 8 different words or sentences that may pop up. Now, when you go to the Mad Libs folder, there's this Mad Lib template. So when you open up that Mad Lib template, you have this. Now please realize we have 3, 3, 8. What that means is these 8 X's represent the 8 options for all 12.5%. So what you need to do is you need to make a sentence. I need to make a sentence for computer math. Computer class. Instead of I could say you. Instead of I or you, I could say she. Need, and then should or wants. Instead of to, they could be do. What's another thing for to? Be.
Oh, no, be to be. She wants to be.
You should be.
Oh, yeah.
That doesn't really make sense. But anyways, you might want to word this so that you have less options on this word. So this should be really, and then this should be need, and then to make. Need, you should really want. You really, and desperately, and kinda. Kinda need, kinda want, kinda should. And so, does everyone see what I mean here? You're just going through and making different variations of this. Please realize making one word each might be really hard. So you might want to make a sentence and have multiple words in this one. It just makes things go smoothly. The other thing I want you to know is you can actually make each cell an entire sentence and it'd be really, really, really long. That's perfectly okay. I would try to keep them be short sentences just because you don't want, when you're outputting this, when you compile and run this, you don't want the text to be going all the way over here. You pretty much have a cutoff about right here because you need to put your debug code then over here, just to give you a heads up on that. So make sure they're not super long. So you need to go through and make your own sentence. That's the easy part. The hard part is just setting it up. So first thing I would do is create this Mad Lib setup, and then we'll go from there. The 3 different types of ifs that you have are else ifs, which have 3 or more options, double nested if, which has 4 or more options, and triple, so it's 4 to 8 options. Because once you get over 8 options, you're basically into the triple nested if of 8 or more options. So the 8 options, these 3, are going to have to be the triple nested if, because we have nothing that has more than 8 options. The reason why these are this way is... Okay, so if you scroll all the way down to the bottom, you have the following code. It's all commented out too. So what I want you to see is we're going to start off with the else ifs. Now the else ifs basically say, if this is true, do this. Otherwise, if this is true, do this. Otherwise, for all other cases, do this. Now the nice thing about else ifs is there we go. Else ifs is you could daisy chain them. By daisy chaining, I mean you could say else if, 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 as many times as you want, and then end with an else. And you'll still take all the options. So this could go all the way up to 8 options or more. Then what we're going to be looking at is the double nested if. So we have an if with an if inside that if statement. And with the else, it also has an if inside there. Now this has 4 cases because we see 4 colons. 1 for each if or else. However, if we scroll down, we have a triple nested if, which means an if inside an if inside an if. Triple nested if. Each one has 1 statement. And notice this is a double nested if inside of an if statement. This has 8 different options. Now please realize there's 2 semicolons here, but this just counts as one option, 2, 3, 4, 5, 6, 7, 8. Now if you need something in between 6 or 8, what you would do is you would copy the double nested if code, and inside one of the ifs you would just put another if statement. And now you have a quasi triple nested if statement because you don't have a if statement inside every if statement, but now you have 5 options. If you wanted to put another one in here, again, you would just copy this and put it inside the else statement. And then you would have 6 options. So let's take a look. The next one we have is, so those are the 3 different types. If we wanted to make 33%, I already showed you 1 through 6, where 1 and 2 are 33%, 3 and 4 are 33%, and 5 and 6 are 33%. But if you're smart, instead of doing 1 through 6, you just do 1 through 3. And then each option is 33%. However, it gets even more fun because if you no longer have to make your random number be an integer. You could just make it so that the random integer is a float, and then you no longer have to typecast with a parenthesis int. That you no longer have to do because you're keeping it as a float, and then the value gives you a number from 0 to almost 1. Right here. And then you could say, well, if you were to say one of these, it would be wrong. This would be more correct, and this would be even more correct because we're not considering all the 0.66666666666. So you still have to do that repeating. So you could say greater than 1 divided by 3, or sorry, 2 divided by 3, greater than 1 divided by 3, and this is the rest of the numbers. And this would be equal to, so you still have that constant where this includes 0. And this would be correct. But these would still be wrong because this 0.331 would be included in this, this would be the biggest. This would be the biggest one, including the most answers just by 1, but still. If you want to be easy though, you could do a random number from 0 to 299 or 1 to 300 and then break them up this way and still get your 33, 33, 33. Please, on the side note, realize that the font size by default is 8 pixels high. So when I look at this, it is 8 pixels high. So if I were to go down here and change the code to, it is overlapping. So it looks like it's 9 by default. So I'm sorry. So this is 9. Let me change that real quick. So what that means is play it safe and just make everything 10 pixels high. Also, please realize that technically, if you wanted to, if you go to Mad Libs under Student Computer Math in the Future Idle game, there is code under Image and Font where you can actually set and change the font by using these 2 lines of code. And then you can even change the color if you want to. Add some spice to your life. And so you can change the font size, put italic, and the font itself. But then this sets the font, this just creates the font. So right here would be the change by 10 on the Y. So please realize we're going back to scale picture here, but you're using d.jawstrings. Then we also have the different primitive variable types. So I have 2 websites here to give you notes if you want to take a look at the notes. But what we're talking about here is integers max value is 2 trillion. A Boolean either has a true or false value. A string is a sentence or a character. A short is only up to about 32,000. A byte is even smaller. The max value is 127. Now, the difference here might not make that much sense for you to even care about. But if you were to think about it, this short is half the size of an int because this is 5 digits, this is 10 digits. And binary always increases the digits by 1, usually for the most part. But what we're seeing here is, initially this was made because memory sizes was very low. And if you had a list of 1 million people, you didn't really care how long it took you. You just want to be able to process those 1 million people and store those 1 million people with few bytes as possible. So now they were going down to bytes for a for period, or for any number up to 100. You could easily use a byte instead of an int. Nowadays, what actually matters is by storing in a byte, you actually do the process faster, which means your games are faster, your loading times are faster, and all that depends just on your data storage usage. What's up? Please realize when you're looking for numbers, if you're looking through an int is 32 bits, that means I have to look through 32 numbers, 0 or 1, to figure out what the value is. I can fit 4 bytes in one int. That means I can search 4 numbers in the same amount of time I could search one int, which that's 1/4 the time, which is huge. Anyways, then we also have floats and doubles, which I'm not going to get into that. But the other thing that I want to show you is we could do a math.random 1 through 6 and then typecast as a short. And I don't even think you need to typecast as a short. It'll just work because this value is of short value. But you definitely need to truncate it so that it's not a float, because this is technically a float, so you do need to typecast it to a short. You could also typecast it to a byte, just like you would typecast it to an int. You're just multiplying it by the variable type. You do not need to typecast a float to a float because it's already a float, just not a root beer float. And then you have double, and you also have long, which long is this really big number that I'm not going to say. So if you're talking idle games, you should definitely be using long for your money. Otherwise, you're going to shoot back to the negatives and your game is going to break. And then chars are just characters. This is the table that explains everything I just went over. The next one I want you to pay attention to, because this is where it gets hard. What you have here is you have 4 percentages that equal up to 100%. I set this to be a random value for x. Now when I'm doing else ifs, it's really easy, because I take care of the less than 30 right here. I take care of the greater than 55, which is my 45%, so I have these two taken care of. And then I say if it's greater than 30 and it's less than 40, which is my 10%, otherwise it's my 15%. And because I know there's only 100%, then I can easily figure out which one it is. Now, what you're gonna the else ifs are easy to set up. That's a no-brainer. Where it gets difficult is the double nested ifs. So I already did one here. I'm going to do another one though. And let's do one with 5 numbers. So what's 5 numbers that equal up to, so what's 4 numbers, anybody? So these are my 5 numbers. What I need to do is I need to increase the inputs of one of these by 1. So what I'm going to do is I'm going to copy my if else. I'm going to put it inside my else just because I can. So now I have a nested if with an extra if inside it. And what I have is I have 5 different outputs. So these don't output the 10%. So I'm going to delete these values. And so what I need to do is I need to group these up some form or manner. I'm going to obviously, if I just look at this, I have 35% and I have 65%. That's a good enough split for me. What that means is these 3 go here because I have 3 outputs. This else means it's down here. So what this means is if the value is less than or less than 65%, But I'm going to actually do less than 66 because I'm typecasting it to an int right up here. So I'm going to start at 0. So I go 0 to 99. It's pseudocode. So if it's less than 65, because realize this should be 0 through 64 is the first 65%. Actually, no, it should be greater than. Sorry, this should be greater than or equal to 65%. Because this will be the rest of the 35%. Now, if it's not greater than, that means it's less than. That means that right here is the 65%. It's one of these two options. So we're going to have 25% and 40%. And if we say it's less than 25%, the 0 through 24, it's going to output for my 25%. Otherwise, it's going to be my 40% because it's less than 65%, but greater than 25% or equal to 25%. That gives me 40% if you do the math, because that's going to be 25 to 64, which equals 40 numbers if you do the math, because we're including 25 as one number. So add one, subtract sort of thing. So now that we have this out of the way, now we're looking at numbers greater than 65. And so if it's greater than 65, I'm going to also do, let's do the 5% right here, because then it's an even 70%. That means if it's less than or equal to, sorry, I already had it typed, 70%, because now we're going to have 65, sorry, no, less than 70%. So I'm going to have 65, 66, 67, 68, 69 as my 5%. That's why it's less than 70%. Now, if it's not less than 70%, it's going to be 70% or greater. So what I'm going to say greater than, I'm going to take my 99 minus 18 gives me 81. So we have 81, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 9, that would give me 19. So I need to make 82. So 82 to 99 equals 18 numbers. This is technically 17 plus 1. So that means if it is greater than or equal to 82, I'm going to get my 18%. And the rest of the remainder is just my 12%. Notice how that's a little bit tricky. You're probably lost. We're going to go through and probably want to go back and listen to it again just to make sure. I also have one up here for these percentages in a standard nested if. So you can go ahead and take a look at that. But again, we're going to look at that later as well. Let's just do it right now, actually. So what we're doing here is we're taking these four numbers. And the first thing we want to do is cut them in half, where we have half down here, half up here. This 15, 50%, 50, 15. This 10, 25, 10, 25. It doesn't matter how you cut it, to be honest. But how you cut it depends on this number right here. So 10 plus 25 equals 35. That's why this is 35 or less than. And then if it's less than or equal to 10, I get my 10%. Otherwise, it's my 25% because it's 10% minus 35% gives me 20%. Now, if it's not less than or equal to 35%, I go down here. That means it's bigger than that. And I can put my 50% up here because that's the easiest one to do. And if it's not greater than 50, that means it's the other bit, my 15%, because it's from 35 to 50. You need one complex string output for each. So what that means is you have a variable plus a green string output on the same g.draw string. The code for this is actually explained down here, where it's the g.teacher plus my green string, which I'm going to put right here. For each means there's 9 of them, which means all 9 of these. The variable here must change if you're only doing one. So to do that, it's the Mr. Fenton versus Mr. T, which if you scroll down is this code right here. You need at least 2 integers, 2 booleans, 2 strings, 2 shorts, 2 bytes, 2 floats, 2 doubles, 2 longs, 2 chars, which is explained up here where you have all these. I already give you one declaration for each one. You just need to implement these into your code. The easiest way to implement the code, they could be anywhere in the program, but you have to use them for something. You just can't declare them and never use them. So to do this, the easiest way is just to use random values. Or you could use those random values in your complex string output, which is right here. So I am the number 1 teacher, or number random value from 1 to 120. Your variables must follow the naming conventions. They should be legible, not super long names. They should start with a lowercase letter, and then every word after is a capital letter, and they can have numbers in it. They should make sense for the value that it's containing. You need at least 6 debug codes. The debug codes is the Yasuo. When you look at the applet, it's the thing that shows up on the right. This is my debug code, where it gives me the value. Please note it's also set up exactly where I'm using it, so I know instantly what's happening. Must be tight, no blank lines. And the percents must be in order. Now please realize what that means is vertically, not horizontally, because horizontally I don't know what order you're putting in the percentages. Whether it's 25, 25, 50 versus 25, 50, 25, I don't know. I can't tell. I mean, I guess it depends on how your if statements are set up, but even then it'd be really hard to pick out the order, because there's multiple ways to order them. But your vertical must make sense. So what that means is the 33% has to be on the top, and this one has to be on the bottom. These two have to be in the middle, in this exact order, vertically, not horizontally. So with your Mad Libs, please make it interesting and have it make sense. What I mean by that is it should at least be somewhat resembling an English sentence. And it must be interesting, where don't just say, my cat walked from my living room to my dining room. That's really boring. At least make it interesting. Need 3 of each type of if, which is the nested if, the else if, and the triple nested if. So we have double nested if. You need to do the function call at least 3 times, which is the get random boolean, which is located at the bottom of the code, which is right here. And the other key thing here is there is a punishment for resubmission. I'm tired of people submitting things that aren't even done, that don't even have pre-post name date period, and are named incorrectly. What that means is every time you submit after the first one, you have to add in an X-nested loop, which starts at 3. So what that means is if it's the second time you're submitting, you need a add on a third nested, so triple nested loop on second submission. And then every time after that, so a quad nested loop on third submission, and add a X5 nested loop on 4th submission, so on and so forth. Please realize this has 8 outputs. This has 16 unique outputs. This has 32 unique outputs. What that means is this isn't that bad of a punishment. This is getting to be annoying. And this is really, really annoying. So this would be 8 outputs. This is 16 outputs. This is 32 outputs. And if you couldn't tell, if you do it again, it's 64 outputs. What means by that is if you submit this program 5 times, you're going to be doing more outputs than you have outputs for the whole entire program, because the whole entire program only makes you do 52 outputs. So by the time you get to your 4th submission, you've already doubled the program, and then on your 5th submission, you're tripling the length of the program. And then you don't want to know. 128 submissions. So this is times, so length of program times 5. Okay, so what we're doing here is, that's pretty much it for the line by line for the requirements. So this is just all the requirements that are done. Please realize this initial code that I gave you has all 9 setups that you need. If you just copy and paste and change the XY values, it'll be all set. Other than that, have a good one. I will see you later.